we are coming towards the sort of end of the project, and then I showed you some examples of how the what do you call projects look like. So, I just want you to concentrate on a few things here and we see how well things will come. So, one of the first things invariably we we end up with is that if you see here, have a look at this real life what I call an electronic enclosure. One of the first things you will notice is invariably we have a top cover, then we have a front cover, and we have a little bit of what I call controls here, and then this also is a control, then we have a display there. So, the earlier the only way we could do all this was to try to make it in sheet metal. So, please have a look at this model in my hand. You see here, this is typically a good starting point. What we used to do was try to make this out of cardboard. Cardboard simulation was the simplest only way of making it. I do not know, I have already shown you, but to make this lecture complete and independent, I will also show you how this was developed. You see here, this is something, this is generic. So, do not be carried away by, sir, what is the function of this, what is this function? While I can probably talk to you about the function, it is not the topic here is saying, if you were to make items like this, earliest was you try to make it in your own, if you have a workshop, alternatively go around searching for it. Now, here it comes to the important thing about detailing. While on the front we have all this beautiful colored, you have seen that there are 4 keys, and traditionally what people used to do is make it into a simple matrix like thing. So, if you can kindly look at this keyboard which I have here, have a look at this keyboard, this computer keyboard. Can you see, I am sure all of us have seen these keys, seen here these 4 keys because of various what you call considerations or anything, you have no choice but to place them like this, because there is no way of making them into a diamond shape. Now, if you see this side, however, there is a provision by which this is the home key and this is up, this is down, and this is towards the left and this is towards the right key. Now, if you just take a little look at whatever people have been doing here, please have a look at it. What these people have done is they have arranged them in a neat, beautiful way. Can you see here? So, I have this home key is here, it is here, and so on. But if you see the outside of it, it looks, seen that it has been put in a diamond shape, because it looks obvious. All we have to do is put an arrow this way and all that. These small details can easily be built when you are doing it in 3D printing with a little bit of an overlay sheet here. Then I spoke to you about the overlay sheet, saying in this case, now let them peel the sheet and see under this overlay sheet we have it. Now you see here we have 1, 2, 3, 4 fasteners holding this key underneath. You understood? And there is probably the reset key or a home key or anything. And intentionally we try to peel it here. You have a look at it, and underneath here you have the display board which I was talking to you yesterday, rather in the previous lecture, saying if you can somehow put all these things into a 3D printed model, and we can make the whole this chassis, and we can either have the what you call overlay sheet, alternatively we can avoid the overlay sheet. Now, you see one very sad thing which often people do. You see here, this is a key. I am not sure whether it, it is either a potentiometer or anything, and unfortunately the letters or the designation for it has been printed underneath, very tough for anybody to read. And similarly, if we were to place it here, we still have this problem, how close do we place it and all. However, for this reset button, no, there was no issue, they could manage it. Oh, luckily it is there, you have seen that after everything has been done somebody by hand, no, has put left and right. So, this sort of things, no, you can say surprises or anything can easily be got over if you do the whole thing in a simple rapid prototyping in using 3D printing. The advantage of this now is this obviously, no, something I do not know, they have written some DBL and so on, no, maybe you can put it there and then you can sort of make these things easier. Now, when you come to the back of the equipment, thing has become much more serious. You have seen this. Serious is we have some potentiometer, I am sorry some what do you call a jack, because easiest to understand, one more jack and one more jack, and imagine after the wire has been placed here, you just can't read it, even as it is we can't read anything. These surprises can easily be got over if we make it up front. You understand, no? The whole thing can probably would have been printed easily and very easy for us to what do you call do it. And then can you see here we have a small inconsistency here, you understood. Generally we have a socket on the wall to draw power from. So, we have a plug which goes on the wall, the end of the plug is a socket and the socket goes here and this is the plug again inside. So, any plug under all conditions, so we have no problem, the power comes in. So, if everything is powered, taken it out, none of these become live. But here to me at least, it looks like a very funny this thing. Logically a plug should have been there, is it not? And the part that goes to the motor, it clearly says output, a socket should have been here and the plug should have come here. But then if you think carefully, there is a little risk also. Risk is saying if somebody takes the mains and tries to do something here, they may create a damage. So, this sort of studies up front, you can easily do it. This one has a switch, then there is a fuse here and all these things. And why I am saying this is, if we were to make it in 3D printing, probably all these objects can be directly printed in, so that we do not have it sticking out. Directly you have a panel in which probably you will have this motor socket which comes out, so that you can put the plug inside, and similarly you have the power input, and all of them is a neat and flush, and then this fuse can be, see there is a fuse here and then more fuse here, like that layout would have been very convenient. Now, if you go further, see what I am talking to you about. So, to me it looks I mean it is fine. This one is from a sensor where you have a 4 to 20 current this thing here. Then we have another what you call proximity sensor and all that something. So, these things various protections would have been possible for you to give. See here what I was talking to you a little while back, the moment you put all this, there is no way of reading anything here. Go further up, it is a cute jungle there. Anyway, my topic is not about this layout or anything, topic is how to make a nice box for it. Slightly improved version is that you see here, instead of those connectors there, this unit instead has these banana sockets including wraparound. You can open it, put open thing. In the case of a professional thing, we have terminations which have screws and which are also protected, and this is in the lab environment. And you see here we have something which is neatly put there. Why this has all been done and why I am insisting for you is, you being in a any sort of a developmental lab, probably these are all generic. Once if you make solid models for this, and it is easy for you, just like you will go to the workshop and then use a standard punch and die to make these openings or standard drill bits, you can easily transfer all these details across all your projects. So, first once in when you start the project, you probably have to spend a lot of time, get the original whatever component you have, and then try to create these things. Now, you see here, just to illustrate, this is a what you call professional, it says Philips multimeter. Now, if you see here carefully, both on the top and bottom, both of them they have given all these designations. Seen that, no? So, in this case it is still valid, because either this is a toggle, means once you press it will go here, once you other press it will come back, or some of them actually stay in place, meaning something goes up and goes down. Now, you have seen here there is some things are written on top, something is written at the bottom, because if you were to write it in between these two, end up with a problem. Hence, they have made all these things. Then I am not very clear what exactly this is, whether it is a buzzer or anything. So, the net result is you have this beautiful layout of an equipment, and if you are to make a library of all these components, you can always attach them together and print whatever project you want. See, it says temperature controller. So, obviously this must be a lab setup, no? Students make these things. Now comes the other thing. Let us say you are in a lab, there are 4 or 5 batches which need to create these things. Instead of everything being monotonous, in this case the whole thing is in the front. It is very much possible for you, if you have to use our RPT techniques, maybe this display, all this stuff can lie on the long side. So, you can stack them. Right now this can't be stacked, this can only be used for one unit. You understand, no? We can stack them. Alternatively, when you in the case of drives and all that, probably you can stack them like this here. So, you can have a matrix of these things for various demonstrations. So, we have come back, I will just quit this. Now, try to show you something else. Here we have I do not know, it is a generic panel which needs to stay at a readable angle. So, if you go to the left side here, you say probably this is the profile. Advantages of working in our scheme is rather saying you now conveniently build all these things. There does seem to be a little error here, is it not? But then this is I am trying to justify, probably intentionally provided. Idea being, you have rubber shoes or rubber feet here. This rubber shoes and rubber feet, this will come all the way down. This is almost touching the place. So, you see here all these profiles and all that, one of the first thing you will notice is they are flat. So, if you have to build it in a what I call a 3D printing, probably if you can split the parts properly. If you see here, this is vertical, this is vertical. So, it is possible for me to build this whole bottom cover in a way, I can build it in a way by which it builds easily. Alternately, I can make it in a flat condition. And the most important thing is here you have seen this has been shown here like this. It be in the case of when we are doing it in our prototyping, probably we can even just take it straight like this. After we take it straight, think about how to assemble these things. This is where we have a nice advantage of working with these things. See here. So, it is very easy for us to. So, the first thing is saying you need to conceptualize your equipment, and if you have it and if you have all the detailing, it is easy for you to go ahead and do your whole build material. Coming back again, this is typically a acrylic what do you call module, which is used for I do not know, generically it can be used for anything, but things are written here, you can read it. And here comes the advantage, saying now this is exactly what the box I was trying to show here. Have a look at it. So, maybe it is a time that you can have a look at it. This is eventually the outside thing we would like to have. Can you see here? In the case of traditional sheet metal, we always split the whole thing into two parts like this. This is made as just an exercise so that a participant can understand. In this particular case, this can be used both by sheet metal work, then it can be used for directly 3D printing, or it can used for just directly laser cutting all these parts, like this and all can be laser cut, or if you want to be little more what do you call careful, especially these bends and all, if you see maybe we can laser cut the whole thing, and then after that by appropriately using some bending technique, and in our case probably it is made with either polypropylene or I mean appropriate plastic which bends over easily, or in the one of the earlier lectures I have shown you polycarbonate sheets of the correct thickness and all that, if you bend over nicely this whole thing can be fabricated. Can you see here slowly, if you see here there is a radius internally. If you are to make it in by sheet metal, easily this can be done, but if you are to make it in our any other thing, a little bit of care has to be taken as these corners. For convenience, the corners have been shown, you see here, it has been shown continuous, same thing here, there is no gap or anything, but in real life because of the spring back, or even in the case of plastic and all that, it is impossible to do it. However, if you were to make these things judiciously, cut them using laser, cut them, and you can always assemble it back with a proper adhesive. So, in the case of styrene based, most of the styrene products they work with chloroform. Alternatively, you can use super glue, cyanoacrylate glue, and except but for the toxicity and various things, very much possible for you to make these openings and all and change the color about it. You understand? No? You can make a small red window here which is shown here. Can you see this? If you see here, we have a red window. Then there are 3 keys here, and if you can put the proper knobs and all that, very easy to make near professional looking equipment. You saw that multimeter picture I showed you. We can easily print a device which looks a little like this. Now coming back to my display here, you will notice, you see here, these are the 2 things intentionally that has been left, kept upside down. So, depending on how you can do it, if you remember carefully, this we have no other choice but to build it like this. If you build it like this, advantage being neatly it builds here, and however here if you attempt to build it like this, we end up with a lot of support material here. So, if you are to make it to lie on one of its sides, now all these planes will become vertical, and in one shot we can build it. Advantage being, in case you want to have an openings here, or in case you want to add things here, or in case you want to have openings here, any openings here, everything can easily be built into the original product. That is where rapid prototyping helps. So, first time probably you need to make openings, take it out, make it out of cardboard and all that. Eventually multiple prints you can take easily, and same file that you have created. In case you have created a DXF or IGS or basic anything, DWG or so many of these either Dassault or Autodesk or Siemens format drawings, they will be accepted by most fabricators. And in fact, if you send out the file, the what you call along with your check is in the mail, not in that, please find enclosed check, most likely within 1 or 2 days you can have these parts delivered. Just for clarification, I was just showing how these things work. While that thing was intentionally built with a thickness, here we have disregarded the thickness when we are first trying to make these things. So, this is more a concept model which is similar to the one I have showed you. The one I have showed you is thicknesses. Here now this is a concept model, you can try it in a flat sheet and a cardboard. After you are happy, and then if you add the thicknesses, the full model can be shown here. You understood? This is without thickness, this is with thickness, but without the corresponding radii and all those things. So, we shall come to the important point that this 3D printing, contrary to what you call expectations or what you call popular this thing, it is just like that, it will not print. You understand? No, you need to understand a little, but fortunately hackers like you and me are out there available, and then maybe you can download something and modify it, and if it is an open source you can play around conveniently with it. Now, same thing you see here, this has been cut into small segments. Now, after cutting it, several options are there. No, I told you one of them is you can probably cut it in cardboard and try it yourself. That was the development model which you have made, or the same thing you can use for laser cutting. In the case of a laser cutting, depending on the thing, you can multiple models you can do here. Now, just as a thing, let us say I have 4 openings for the thing here, and for connectors I can have openings similarly on the side, and if you see, this is the inclined front surface which matches here. So, here I can have all the openings meant for various controls, displays, any other units here directly. And as I was telling you earlier, you can probably use it, you can save a lot of material if you print it flat. You understood, no? Since here there are no openings and then there is a small thing, making it, building it in this condition is desirable, because nothing else, no further processing is required. However, when it comes to this inclined surface, we are likely to end up with lot of support material lost, and whichever way orientation you make it, you may end up with it. But in this case I told you, you can put it on one of these edges, but then even then this material inside, little bit of post processing is required. After the printing comes out, you have to probably knock it out and then sand it a little, and anyway this requires all the post processing. So, I will come to another what do you call convenient way of building full fledged sealed boxes. So, if you see here, this is actually a model that has been created some time back. Looks fine, absolutely no problem, isn't it, except that to save material and also to have all these things. Somebody has worked a lot of in detail. This front stuff has been made with transparent material. Right now it is very much possible for it to print transparent material, and if let us say you do not want the contents to be visible, you can always put a decal or a sticker on top of it, and this typically these proportions and all for an initial thing you can get it from the internet from various suppliers. And the magic is, sadly, like most things, you will never have a perfect fit or anything. There is no one side which fits all, whether it is shoes or whether it is your clothes or whether it is I do not know, no, various other things. So, you may end up with a enclosure which is not deep enough or too deep, not shallow enough for you, and all the other dimensions. No, and you will end up with something which is tighter or something which is unnecessarily extra area. Those times, no, if you have to ask the manufacturer of this, that is going to be a big nuisance. So, what has been done here is, let me go back a little and see. See this is the final box seen here, and you will notice that there is no split line saying where do you close it. And in the case of a what do you call actual injection modeling, probably all these radii are important, and further you cannot afford to have sudden change in cross sections, but you need this corner strengthening is required. So, but when you attempt 3D printing, no, it is relatively easy for us. In fact, if you make these like this and then if you print them with this base down and print it up like that, these things come out very well. Now comes the other thing, if I told you, no, can we add a threaded insert? So, depending on how serious it is, if you can have a through opening, it is very much possible for you to put a threaded insert. One side you can put there, one side you can put here, and enough clamping force can be given such that the cover can sit properly, and the cover itself can be made in opaque material or it can be made transparent. In this specific case, if you make too many openings, chances are things will leak. Instead, you can make it with a transparent cover, because it looks like clear various clear materials will be there. I think in third or fourth lecture I have given you idea of what are the materials can be used, and you can print it with a clear cover. You can always put a fascia. If you put it inside, it looks clean. If you put it outside, you have some advantages and expose only the same areas as you have done in that sheet metal, that exercise which I have shown you. So, you see here now, see at the back we have this, or in the front. Let me go forward for something how to make use of the same thing in the case of, let us say you need to make a small cup. This cup is required for you to hold maybe some torch cells or maybe a sensor or anything. So, if the manufacturer has not given you a recommended enclosure, creating such things and printing them is extremely easy, you understand. So, you must make a model of the contents. It could be a simple printed wiring board which has all the various displays and sensors, and then after that if you make it, printing this is extremely easy, and up to maybe a few hundred models, easiest is to carry it like this. Small difference here, if it involves strength, we end up with having to give all this corner reliefs because bending is involved. So, since the advent of printing, all the small things earlier which we used to unnecessarily concentrate on how to make these things, which is probably just of the early industrialization, everything was made out of tin cans. I have shown you a box of mints, that blue colored box earlier. It is made with a 0.4 millimeter galvanized what do you call mild steel thing, formed like this, including a lip and all that. Now, all this can very quickly without too much of thing, either you can make it like this or you can happily print the object directly here, which I think is a really it is something. So, now you have seen this with the reinforced corners. Now, what has been done is, let us say you need to make it in using sheets that are cut directly in a laser cutter. In the case of laser cutter, unfortunately unlike the 3D what you call printing, you need to reinforce the corners separately by these items. So, this has been done just to show, no, yeah, maybe start here. You see here, this is our original drawing, 120 by 60 by, I think this must have been around 35 or 40 millimeters, and the small things, no, we can attach them. See here, if you go into the corners, little bit of this overlap is there. Why is this overlap and why the detailing is being what you call stressed upon is, so when you make it out of pieces, we still have this problem of how to compensate for all these physical thicknesses that are required. So, this can be a strong, probably something an extruded, typically it could be a glass filled nylon rod, or so many other materials are available which can easily be attached to the thinner, flatter material. So, the thing is this to what size you need to what you call turn them and all the details have to be worked out. Now, see something which has happened, this only for what do you call more for see these corners, when we come to these corners only for convenience I have added this radius. You need to find out what thickness sits where, and all this compensation have to be given. This reality of these physical things does not go away, and earlier workshop people know, I mean rather the machine shop people were very much familiar with it. Same thing it is with whoever makes injection molding, whoever makes the molds and all that, no, without telling you they try all these exercises. So, if you are in that area, now you know that the 3D printing, no, is easily, it will help you in making all these things here. Now, see here, a cover is being placed, one cover is at the bottom, and so we have this beautiful things which are very much to be possible. Now, I thought I will just show you here now. This is the starting point. While in the starting point everything looks fine, we have a neat cute 40-80 and all that, thickness is not been shown here. So, as you develop these things, you are expected to have all these details worked out. This is the same thing how it looks outside. If you were to take a little closer look at these things, there are a lot of these small details, no, including a key like thing which makes these things hold together. These are all maybe you can directly try to first time from the market you can get these things, and maybe part of this file, the file itself may not be used, but all these drawings and layout, no, easily you can continue to get it from the, you have seen this just details. So, you see here there is a serial port, and why I am insisting that you see all this is, it is not enough if we just make an opening for just this, which we are likely to first time, no, first time several of our users, you may not have seen this serial port. You will notice that it has a hood assembly on the outside, and you need access such that the hood, hood comes and sits here comfortably here. Hence, these openings and all have been worked out, and once you keep it in place and get your thing ready in a semi professional setup, most likely one way is try to ask those manufacturers whether they will make it for you. If you have to ask me, if you are an electronics person and not a simple hacker, it will be much easier for you. Ask the manufacturer, they saying, I have a new thing by which probably I do not need a Ethernet input, and I have probably something which is already built inside. And in the case of this USB right now, from the standard thing USB C is getting in place. Advantage of C is being you can, like the lightning cable, you can insert it in any direction you like, and they have also increased the speeds. So, you see here that is the locking key. After putting it in place, they have got a plus like thing and all that. These details you can easily see, and if it is a generic case you need to make all these things. I think probably we have come to the end. So, you probably start with the base and then you have all these I do not know whether they are it says audio come in something in and out, could be an audio jack, and then this is which very clear 5 volt input. The product you are going to make may not have a 5 volt input, it may be stacked inside. If there is a place here, no, maybe you can put a stack and maybe you can have a 3.7 volt lithium ion cell, and you may just need different charging port, you may not want to use this. So, all those things you can easily build inside. Just I just had downloaded it, I thought no, you should see how these things, no. The other model I couldn't locate it somehow, thanks to the thing. This is all cut as a trial piece. Even before you fire a job, it is very easy for you to make these things. They are not impossible for you to make. You see here all these things how they have been made, and finally it just works. I did not do it, of course. There is one of my colleagues is an expert in these things, and then finally we have it here. And now when you want to convert it into sheet metal, these corners we end up into these corners. Same thing happens when you have it with 3D printing also. You cannot ignore these reality thicknesses and all that. So, now you saw the box which I showed you. When it actually comes from the often in the kit form, it comes in this. It looks a little like wood, but then when you do the laser printing, what is done is it comes with a backing sheet on both the sides. So, the trimming is done with the backing sheet, and then you have all this hardware which is kept here. So, you need to keep it in place. Usually instructions are available, and the magic is you can make it yourself. If you are making a particular thing, you may not need to all that. Say for example, this is on the go, you may not need SD card socket, you may not need, and power in this case it says 5 volts, maybe you can have other requirements also, and not often the serial buses are used these days. So, you can always print your own thing which has all the other features, but these are blocked actually. So, you will have then he has given everything, probably I am not sure what is it, audio in and out and DVI and so on. So, I thought I will be able to show you. You see all these things. Beagle bone black. See this here, it has been stacked. Same thing, stacked, and actually there are screws here. So, these fasteners hold it in place. Something else again. So, why not make something which sits neat here. If you remember, it is taken from that. There is some, maybe this is the USB jack and maybe this is their power supply serial port, and just by making the top and bottom overhang like this suddenly that boxy appearance has been removed, and instead of one getting into the other, you see here most likely this top portion is one and the bottom portion is one. If you examine it carefully, printing these two is very easy, and no support material is needed because it has been split neatly. So, both the pieces can be printed flat. After printing it flat, just put them together and nicely we have a beautiful enclosure for all practical purposes. And then this of course I have already shown you. So, I will now go out. So, you see here, this I have already shown you. I will continue tomorrow with something. I have a video which has been taken from in the workshop about a machine shop operation that is going on, and even this machining things and all that, we have ended up with little reality problems. So, if we were to actually make a model 3D model and then print it, it would have been easier and would have saved time by making it into a half scale model. So, overall the volume will be 1/4 of the volume and very nicely, I am sorry, 1/8 of the volume, and we would have had a small item. We will see how things fit together later on. Take it to the machine shop and have the fabrication done. So, thank you.